Alright folks, this is going to be a problem of section 10.2, 10.2 being limits continued. So we're going to do the first problem. The first problem's here in front of you. It gives us this piecewise defined function which has all sorts of weird parts, and it asks us to evaluate all sorts of limits. It has parts A through K, so I'm just going to do them all in one shot here. Okay, so the first one is evaluate. Okay, so the prompt is for the function f given in 10.21, find the following limits. If the limit does not exist, so state that, or use the symbol infinity or negative infinity where appropriate. So the first one is the limit as x approaches negative infinity of f of x. So as x approaches negative infinity, meaning that x is going off into negative land this way, we see that the function is increasing, and it likely is increasing infinitely. And so for part A, the answer is infinity. For part B, the limit as x approaches -1 from the negative side of f of x. So we're looking at a one-sided limit here. So when you have this negative on the right, that means we're coming from the negative side, from the negative values of x, and they are increasing towards the positive values. So as x approaches -1 from the negative side, we see that the function is approaching infinity. And so the answer to part B is also infinity. Part C. The limit as x approaches -1 from the positive side. So again, we're looking at one-sided limits from the positive side, meaning we're coming from the large positive values and they're getting smaller and smaller. And we're approaching -1 from that side. So we can see that from that direction, the function, as we approach -1 from the positive side, the function seems to be going down to negative infinity here. And so for part C, the answer is negative infinity. D. The limit as x approaches -1 f of x. Well, we know that as x approaches f of x from the negative side, the one-sided limit from the negative side, it approaches positive infinity. As it approaches -1 from the positive side, it approaches negative infinity. So since the two one-sided limits are not equal, then we say that the limit does not exist. So for part D, it does not exist. E. The limit as x approaches 0 from the negative side. So as x approaches 0 from the negative side, we can see that the function is approaching 0. And as x approaches, so for E, the answer is 0. So as x approaches, again, so from the positive side, as x approaches 0, it's approaching 0. Even though we see that at the actual point x equals 0, y f of x equals 1. So evaluated at that point, the value is going to be different. But the limit, as we get closer and closer to 0 without actually getting to 0, from the negative side, the function is approaching 0 for f of x. And okay, so that's part E. Part F, the limit as x approaches 0 from the positive side. Again, approaching 0 from the positive side, we see the function is going down to 0 again. And so from the positive side, the limit for part F is also 0. Part G, the limit as x approaches 0 of f of x. So again, the two-sided limits need to be equal in order for the limit as x approaches 0 to exist, and they are. We figured out that in part E and part F, both of the limits are 0, and so part G, the limit is also 0. Part H, the limit as x approaches 1 from the negative side. So as x approaches 1 from the negative side is going to be this direction. We see that f of x is approaching 1. So for part H, the answer is 1. For part I, the limit as x approaches 1 from the positive side, well, we see that as x approaches 1 from the positive side, it is approaching 2. So for part I, the answer is 2. For part J, the limit as x approaches 1 f of x. So again, we just evaluated the two one-sided limits, both from the negative direction approaching 1 and from the positive direction approaching 1, and we figured out that the limits are different. We have 1 from the negative side and 2 from the positive side, and thus for J, the actual limit as x approaches 1 of this function f of x does not exist because, again, the one-sided limits are different. And for part K, not to be confused with the butter substitute part K, the limit as x approaches infinity of f of x. So as x approaches infinity, so as x gets larger and larger and larger forever, we see that the function stays constant at 2. And so the limit is 2. So for part K, the limit is 2. And that concludes this question.